All right, guys, in this video, we're going to be looking at a free response three-part question for heat transfer and thermal equilibrium. So we get this graph, and it shows temperature versus time. The student did an experiment to determine the specific heat capacity of a metal alloy. The student put a sample of the alloy in boiling water for several minutes, then quickly transferred the alloy into a colorimeter containing water originally at 25 degrees Celsius. The temperature of the water was monitored over time. The data are given in the graph above. So A asks us to solve what is the value of delta T that the student should use to calculate the Q, the heat gained by the water. So this graph shows us the temperature change of the water, and we want to do T final minus T initial. It is always going to be final minus initial. So in this case, the final temperature is right here at this point. This looks like 26.4 is that final temperature. And we want to subtract that from the initial temperature, which was at 25 degrees Celsius, as shown in the graph and told us right here in the question. So by subtracting those two, we get 1.4 degrees Celsius, and that is the delta T for this question. So part A is just 1.4 degrees Celsius. B, in terms of what occurs at the particulate level, explain how the temperature of the water increases after the alloy sample is added. So we want to indicate that the atoms of the alloy transferred kinetic energy to the water molecules. Okay, because that is how that's how temperature works, right? Temperature is a measure of average kinetic energy, and in this particular example, the alloy transferred kinetic energy to the water molecules. This slows down the alloy's molecules and increases the kinetic energy of the water molecules. So by explaining that, we should get full points just by this statement right here in explaining how the temperature of the water increases after the alloy was added. Part C says, the student claims that thermal equilibrium is reached at time t. Justify the student's claim. In your justification, include a description of what occurs at the particulate level when the alloy and the water have reached thermal equilibrium. Okay, so first off, right here is time t. And do we agree that it's reached thermal equilibrium? Yeah. And in my response, I'm going to want to agree because at time t, the temperature is no longer changing. It's reached thermal equilibrium. We're not seeing any more changes in temperature. So two parts to this question. We want to justify. So we'll say the claim is correct because the temperature levels, I'll just say the T levels, the temperature levels off at time t. So we should write temperature here to separate those two. Okay, so claim is correct because the temperature levels off at time t. But we also, this is a two-part question. It also then asks us in the justification include a description of what occurs at the particulate level when the alloy and water have reached thermal equilibrium. So at equilibrium, the average kinetic energy of the atoms in the alloy is equal to to the, sorry, this gets lengthy, average kinetic energy of the water molecules. We could probably write that a little simpler. We could say at equilibrium, the average kinetic energy of the alloy and the water molecules are the same, or something like that. But this is definitely what you're looking for to write. So part one, you want to claim that, or say that the claim is correct because in the graph the temperature level is leveled off at time t. And then part two, the average kinetic energy of the alloy and the water are the same. So hopefully those three questions helped you a little bit with heat transfer.